All right. Okay, so this is what's happening today. We are looking at Monday, April 6th, which is our 11th day of distance learning. My favorite number, guys. So we are going to be looking at distance in space and relationship between objects in space, which is the first two projects in Project Space. The objective today for our distance in space is that you will recognize that there is enormous distances between objects in space, and you'll be able to apply the knowledge of light and space travel to understand this distance. And the girls are going to help us to understand it today. And then our next group will be teaching us that you'll be able to recognize that the universe contains billions of galaxies, and each galaxy contains billions of stars. So those are what we're hoping to understand today. And the materials you need are the Project Space presentation packet that you should download off of EdSpeed. And then we are going to play two Kahoot games. So this will be our first time trying to play Kahoot this way. I think it's going to work. And it probably would be easiest if you were using your computer right now and then had your phone handy to actually play the Kahoot on, for your answers. So that's what I am suggesting. If you don't have a way to play Kahoot, that is okay. It's not going to be for a grade for you as an audience, but having a quiz for your project was a requirement of the project. So you do get a grade for it as the person who made the quiz. So the video is going to start in just a minute. We're just making sure that everybody is here that's going to be here, and it's looking like quite a few of you are here today. Wish there was a way I could see how many of you. And there probably is a way. But all right, so we just to make sure that we are all on the same page. There were a few of you that joined us just a minute ago. So don't forget that this is the Project Space presentation packet that you are putting your answers. You're answering these questions while looking at the video for the project. So when we are listening to Lola and Jana and Maddie show us or teach us about distance in space, we're going to be answering these first 5 questions in our packet, and then we will take our Kahoot quiz, and then we will listen to Maya, Courtney, and Nova present relationships between objects in the universe, and then you'll answer these 6 questions. And after each presentation, before their Kahoot quiz, you will have a chance to ask them any questions that you might have that you didn't get answered during the presentation or that you didn't quite understand. All right, so let me see if there is anybody right now that is having any questions about anything that's happening right now. Oh, we got a couple more people joining us. All right, welcome Maya, welcome Devin. I thought you guys were, Devin, I thought you were in already. Maybe you had to leave and come back. Okay, so does anybody have any questions before we get started on what we're doing? It looks like Jacob might. Yes, Jacob, you're on. Jacob, did you have a question for us? Jacob, you have your hand up. I have you unmuted. All right, Jacob does not have anything to say. Maybe he accidentally raised his hand. And I did see Jules' hand up. Yeah, hi Jules, good morning.
Hi, first off, Jacob just said that he can't use his mic. So.
Oh, okay.
And then the second thing I want to say is, do you have to answer the questions for your own presentation?
Oh, great question. I am glad you asked that, Jules. Yes, I would like you to answer the questions for your own as well. Okay. And then you will be turning this in for a grade, but not today and not tomorrow and not even this week. It'll be when we finish. the last presentation, and I'll give you a heads up on when that'll be. It should be, if we do 2 a day and we're on our block schedule where we're only meeting really twice a week, because we don't have school Friday, so we would be meeting 3 times this week, but we're not, just Monday, Wednesday. So it should take us 5 class periods to get through 9 presentations, which would bring us, give us about 2.5 weeks on our block scheduling. All right, so thanks, Jules. And then don't forget, when you raise your hand, if you are done asking your question, lower your hand, and then that way I won't think you still have a question. So Jacob, you can lower your hand now, and if you do want to say something, Jules let us know that your microphone doesn't work. You can always chat. So I do have the chat function open, so you can type us a message if you want to say something. And you can always raise your hand to get my attention too. If you do that, the chat, and it doesn't work, raise your hand and then I'll know to look for you in chat. Yeah. All right. Excellent. Well, I am looking forward to this. And if anybody else has a question, now is your time to ask. Otherwise, you should have your this packet in front of you, and we're going to go ahead and get started. So all right, let's see here. All right. I'm hoping that this is working. Evan, good morning, Evan. How are you?
Good, how are you?
I'm doing good too. Thanks. Newton says hi, by the way. Evan, do you see on your screen right now a screen that has lots of blue circles that say light year and astronomical unit and that kind of
Yeah.
stuff? All right, this is the beginning to Lola, Maddie, and Jana's presentation. So it looks like you're able to see it. So let's go ahead and play it. And we'll play it all the way through, and I think it's about 8 minutes long. And then if you have questions at the end, maybe jot a question down in case you might forget it, and then you'll ask at the end. Okay, here we go. Oh, I think there's a way. Wait, I'm supposed to do something about video. Let's see. Something about optimizing video. Okay, sorry, I don't see that. Hopefully this plays all right. Okay. Uh-oh. I don't hear volume. Evan, do you hear volume? Oh, shoot.
No.
Me neither. Well, I heard volume before. Okay, so I am so sorry, guys. We're kind of learning this all together. Let's see. Somewhere there must.
There's a way to fix it. You go to the I think it's the audio.
Okay, here we go.
Light year. A light year is how far light can travel in 1 year. It is 93 million miles or 150 million kilometers.
Astronomical units. What is it? An astronomical unit is the distance between Earth and the Sun. An AU is approximately 93 million miles or 150 million kilometers.
When would we use them to measure? AUs are used to measure distances between objects located in our solar system because it's a smaller unit than a light year. Well, light years are larger than AUs, and they're more commonly used to measure distances outside our solar system.
Light years and AUs. Light years and AUs are used when measuring distances in space as opposed to feet, yards, or meters because we would have to use larger numbers for larger spaces. And to simplify, we just use bigger units for bigger spaces.
Okay, now we're doing our models. I'm representing the sun.
Maddie, are you talking?
Yes, this is
Is
the
what?
sun. And then Mercury.
So this is Mercury, drawn by my sister. And it is 40.8.
The wrong way.
Yes, it's on your Prezi, right?
Well, it's Lola's holding it.
No, I don't. I still see the Prezi.
Can you see all of us on the side?
No, wait, hold on.
Okay. This one. So, is this my planet? What planet is this again? Oh, Mars. Sorry, I forget. I have two. So, this is Mars. It is 1.524 AUs, 141.6 million miles, and 0.000023679 light years away from the sun.
And then this is Jupiter. Jupiter is 5.203 AUs away from the sun, 483.6 million miles, and 0.000822237 light years away from the sun.
This is Saturn. It is 9.539 AUs, 886.7 million miles, and 0.0001583 light years away from the sun.
This is Uranus, and it is 19.818 AUs, 1,784 million miles, and 0.0003132 light years away from the sun.
This is Neptune. Neptune is 30.06 AUs, 2,794.4 million miles, and 0.0004731 light years away from the sun. And that's it for the planets.
Okay. And then were you done with the Prezi or?
Oh, there's more.
Okay.
So the closest black hole we know of is V616. I don't know how to pronounce that. Monocerotis. It's located about 3,000 light years away, and that's just the closest black hole. But there are several other black holes that we've discovered, and they're all several thousand light years away from us.
International Space Station. The International Space Station is 254 miles away from Earth.
The moon. The moon orbits in an oval shape, therefore it is not a constant distance. However, the average distance of the moon is 237,700 miles.
Maddie, are you able to share your screen for the Prezi again?
I'm not?
No, we see your. I'm not seeing it anyway.
I can see it.
You can see it?
I can see it.
Yeah.
Well.
Yeah.
Oh, okay. Well, I'm not seeing it for some reason. Okay. All right, we'll keep on going then.
Okay, so starlight. 1 light year is about 6 trillion miles, and how long it takes us to see a star depends on how many light years away it is from us. Examples. Our sun is 8.3 light minutes away from us, so it takes us about 8 minutes to see it, while the nearest star is 4.3 light years away, and it takes us 4.3 years to see that.
Time travel. Is it possible? Theoretically, it's possible. We just have to figure out a way to travel faster than the speed of light.
You can
Did someone say something? Oh, sorry.
It's
If
just,
one were to depart, I'm sorry. If one were to depart from Earth in a spaceship that could accelerate continuously at a comfortable 1g, an acceleration that would produce a force equal to the gravity at the Earth's surface, one would begin to approach the speed of light relative to the Earth within about a year. As the ship continues to accelerate, it would come even ever closer to the speed of light, and its clocks would appear to run at ever slower rate relative to the Earth. Under such circumstances, a round trip to the center of our galaxy and back to Earth, a distance of 60,000 light years, could be completed in a little bit more than 40 years in ship time. Upon arriving back to Earth, the astronaut would only be 40 years older, while 60,000 years would have passed on the Earth.
That's interesting.
And that's
That's
it.
it.
Is that it?
Mhm.
Okay, I'm going to stop recording now. Okay. And Maddie. Okay. All right. Maddie's going to be the host. Share screen. Oh, no. I think. Sorry. Okay. All right. I think that you can. Oh, there we go. Okay. You are not. Okay. Get rid of that. Okay, so I think you guys have questions. And I'm sorry, that was a little bumpy. I didn't realize that it was quite as choppy as it was when I picked that one, but I did think they had great models that we couldn't quite see all of them. All right, so we've got some questions, and let's hear from Libby. Libby, what kind of question do you have?
Well, the main thing was it was just kind of like I couldn't get any really answers because I'm looking at the packet and they're already done talking about like 4 questions ahead. So a lot of people in chat were also saying that it was going way too fast, even though it was an already pre-recorded message. We can't really change anything about that. But the next time we do it, can we like pause after every question so at least we can write something down? Even though I know it's recorded and we can go back and watch it later, it was just really fast.
Okay. All right. Yes, I can. And that one actually had quite a few technical difficulties that I think I've got them ironed out in all the rest of the presentation. So I apologize about that. Our first one there, they've got the information in there, so we can go back and answer these questions now. And yes, in the future, I will pause in this next one. So, okay, I'm sharing the screen with the presentations there. Okay, who has a question for the group? Actually,
Why did you unmute us all?
I just muted you all again. Let's see. I'll mute you all. I'm going to. I thought I did. Now
Chug jug.
okay.
All unmuted.
Jaden.
Yo!
What's up, guys?
You were all unmuted.
Oh, hey.
You know, I can't say.
This is gonna be so great.
Hey, shut up, Leo.
You should all be muted again.
I don't know about that.
I can smell your
No.
milk dud breath.
I'm pretty sure we're not muted.
All right.
August,
Yeah.
you're right from all the state.
Okay. Can you guys put yourselves on mute then?
Spoiled milk.
And then who I want to be unmuted is
No, it's
Donna,
great. So great.
and Maddie and Lola. If you guys could, the three of you could unmute yourself. Everybody else go back to mute. For some reason, my mute all the button does not seem to work. I don't know why. Okay, so Jaden, do you have a question for the girls?
Distance of an astronomical unit and the distance of a light year and the distance between the sun and the earth in miles, light years, and AUs.
Okay. All right. Who wants to take on how far a light year is? Go ahead, someone, Jana or Lola, Maddie. You're not unmuted. Right. Lola's unmuted. Lola, how far away is a light year? She can't talk. Oh, we're doing it in chat? Okay. Why isn't anyone talking to me? I know you're unmuted. Maddie, Lola, or Jana? All right. For some reason, they're not unmuting. Okay, Maddie, can you hear me? Maddie.
Yes.
Okay. Hi. And Jana, I'm unmuting you too. You should have been able to, you were unmuted. All right, there's Jana and Lola. You're unmuted. Okay. Somebody let us know how far a light year is in miles.
I'm trying to open the Prezi. It's loading.
You
All right.
have your answers.
A light year is 43 million miles or 150 million kilometers.
No.
Oh wait, is that? I think that might be the wrong slide. Hold on.
Okay, a light year is 6 trillion miles. Okay, who can tell us how far an astronomical unit is? Okay, girls, I kind of need you to be here with me here. I'm going to go ahead and answer all these questions now because this is needs to be answered. We have to keep going. So, all right. Somebody else asked. Jana says, "I'm not unmuted. You should be, and you can unmute yourself." I unmuted you. Why are we muted again? All right, Jana.
Hi, I'm back.
Hi.
Sorry about that.
Okay, I am too. I thought I unmuted you. Okay, Jana, how far is an astronomical unit?
An astronomical unit is approximately 93 million miles.
Correct. Okay. All right. I think we answered Judy's questions, but I'm not quite sure if we did. So you can ask again. Liam.
Oh, no. I just forgot to lower my hand.
Okay.
I'm
Mia.
sorry.
Wow, Liam.
Yeah, I'll mute.
Okay. Mia, do you have a question? Mia? Hello, Mia. Your hand is up. Do you not hear me? You are unmuted. Okay. Well, Jaden, do you have another question?
Yes, sorry. I just didn't get, what is it? What is the distance between the sun and the earth in miles, light years, and AUs?
Okay. All right. Girls, do you want to take that? The distance between the sun and the earth in miles, light years, and AUs.
I'm unaware of how far the sun is. Wait, the sun from Earth? I think I got the question confused. The sun from Earth in miles and AUs.
Yes.
So Earth is and okay. So Earth is 1 AU away from the sun, 93 million miles away from the sun, and 0.000015755 light years.
Okay. And guys, for light years, you really don't need to know that number in light years. But what you should know is that it's less than a light year, and actually it's 8.3 light minutes, which you could put that one down, 8.3 light minutes. It's a lot less than a light year because remember, a light year is 6 trillion miles, and the distance between Earth and Sun is only 93 million miles. Okay. Jaden, did you have any other questions?
Nope, that's it. Thank you.
Okay. All right. So we're going to try to play this Kahoot game now. Wait, no, we've got a few more questions now that are starting to pop up. Okay. Hannah, what's your question?
What is the second part for for question 1 and 2, and what is the answer for 4 and 5? Because I wasn't able to get any of the answers for those.
Okay, girls, where would you use a light year to measure distance?
Is Maddie and Lola on here? Because
Good
they haven't been
question.
talking.
I mean, Lola and Maddie are both on here and they're unmuted.
Yeah, I'm right here. It's just my internet's down and I can't pull anything up.
Okay. All right, guys. So you would use a light year to measure distance outside of our solar system. And actually, Jonna, do you want to take these answers? Because me taking them isn't helping your skill.
Yeah, I can take some of them.
Okay.
So was it 4 and 5 you had a question about, Hannah?
Yeah, and the second part of number 2.
Where would you use an AU to measure distance?
Okay, well, so just the nearest. Hold on. Sorry.
An AU would be used to measure distances within our solar system.
So for number 4. So for number 4, the distance of the nearest black hole is 3,000 light years away.
Okay. 3,000 light years away. And number 5, if the nearest star is 4 light years away, how long will it take us to see its light?
Sorry. So if a star is 4 light years away, then it would take. So it always depends on how far away a star is, but it would be about.
And I will tell you that Lola is answering here in chat. She must not be able to use her microphone, I guess. She's saying 4 years, and that is correct. it would take 4 years because a light year is how far light travels in 1 year. So if something's 1 light year away, then it would take 1 year for us to see it. And if it's 4 light years away, it will take 4 years for that light to reach us here on Earth and for us to see it. Okay. All right, Jonna, let's see if we can't bring up your Kahoot and see if we can't play it. All right. Oh, Kevin's trying to come in. Okay, so wow, that took a long time. Okay, so let's see if we can, you know what I think we're gonna do? I think we are going to go ahead and do this next presentation, project number 2. And then we will try to play the Kahoots, both of the Kahoots after, and see if that works better time-wise. Okay, so we are going to move on to relationships between objects in the universe, project number 2. This one is with Maya, Courtney, and Nova. And I will pause to get this pulled up. And you guys will hopefully have a little easier go at this one. I'll try to stop it you know, best I can, so that you can answer the question so it doesn't go so fast. Okay, so let me share. Okay. Okay, I wonder if we're seeing this. Cooper, how are you, Cooper? You're not unmuted yet?
Hi.
Hi, how are you, Cooper?
I'm doing pretty well. Is there a reason why I'm unmuted?
Yes. I want you to tell me if you can see the screen right now that says relationship between objects in the universe.
I can see it. Yes.
Yes. All right. Does it cover your screen?
It's not like it's not in full screen. I mean, I still see your the participants on the side of your screen and the chat on the side of your screen, but other than that, it's fine.
Did not know you could see those things. Okay, good to know. All right. So we're going to go ahead and start this one. I will try to pause. If you guys see a place where I should pause, maybe raise your hand. And I will know that I should pause there. I think.
Yeah, because the last one was a little bit fast.
Yeah, it was. I'm sorry. I thought that would go a little smoother, and it didn't. But let's give this one a try. Okay, here we go.
So the relationships between objects in the universe. Yeah.
Okay,
it worked.
All right,
That's fun.
You got me? Okay, I paused it for a second. Can you guys hear it? Let's see, Cooper, I think you're still unmuted. Can you hear it okay? No, he's not unmuted. Chase, do you hear it? Chase, can you hear the video?
I can.
Yeah, okay, awesome. Here we go.
Okay, so this is the relationship between objects in the universe.
So the rank. Oh wait, you want to say?
Yeah. The rank from smallest to largest would be planet, star, solar system, galaxy, and then the universe.
And I paused that. Hannah asked me to. So yes, that is the order that it goes in.
And then this is actually, I don't know how is it working. This is like a really long thing where you can see like how far away everything in the solar system actually is. Like really far.
Oh, I don't see it.
You don't see this? And our planet is split into 4.
Sorry, darn it.
This is like a really long thing where you can see like how far away everything in the solar system actually is. Like really far.
Oh, I don't see it.
You don't see this?
No, you might have to hit share.
Oh. But you just see the PowerPoint?
I just see the PowerPoint.
Okay.
Yeah.
Well, we'll go back to that.
Okay.
So we'll start with Earth. The major elements in our planet are oxygen, silicon, aluminum, and iron.
All right, I paused that there so that you guys can, somebody said they're having trouble seeing the whole PowerPoint. I hope that helped, moving my chat there.
This is silicon, aluminum, and then this is iron. And our planet is split into 4 main components: the atmosphere, hydrosphere, biosphere, and lithosphere. And then in the atmosphere, there's mostly nitrogen and oxygen, but then there's also a little bit of argon and carbon dioxide, and then a little bit of other gases. And in our planet, there's 71% water and 29% land.
Oh wait, that's my friend. Okay, so galaxies. You click the button. How many galaxies exist in the universe? There are at least 20 trillion galaxies in the observable universe, which, you know, there's a random number. A lot of zeros. So what tools show, wait, this is your question.
Oh yeah. So astronomers use Hubble to analyze images that are taken deep in space. It was launched in 1990 into low Earth orbit, and we still use it all the time. It wasn't the first telescope that we used, but it's one of the largest and most versatile, and it's very vital to what NASA uses. And then here are a lot of pictures that Hubble has taken in space. It's just pictures. And then this is a short video.
Oh, yeah. Cool.
Okay, so solar systems and galaxies. The definition of a solar system is one collection of 8 planets and their inner moons in orbit around the sun. Together, the smaller bodies in the form asteroids, meteors, and comets. The definition of a galaxy: a system of millions and billions of stars together with gas and dust held together by gravitational attraction.
Pause for a minute.
Click the button. What is the difference between a solar system and a galaxy? The difference is that a solar system is a star in the middle and planets orbiting with other objects. A galaxy is made up of billions of solar systems and other objects held together by gravity. There are 3 types of galaxies. Irregular galaxies have no regular symmetrical structure. They seem to have large amounts of dust and look at the most light from the stars. All of this dust makes it almost impossible to see distant stars in these galaxies. There's a picture right above it. Spiral galaxies, which stars as gas clouds, are concentrated mainly over one or more spiral arms. Spiral galaxies have 3 main components: a bulge, a disk, and a halo. The bulge is a special structure found in the corner of the galaxy. So, there's the picture. Elliptical galaxies are shaped like spheres or elongated sphere in the sky. We can see two of their 3 dimensions. These galaxies look elliptical or oval shaped disks. A rose galaxy, fun fact, the larger of the spiral galaxies, known as UGC 1810, has a disk that is disoriented by a rose-like shape, by the gravitational tidal pull of the companion galaxy below, known as UGC 1813. The Milky Way. So why is it called the Milky Way? The name Milky Way comes from many different cultures. The Romans called it, I'm going to try and pronounce this, Via Lactea, which translates to road of milk. They called it this because it looked like a milky patch above the earth. The Greeks called it Galacteus Colucus, which translates to milky circle. How big is our galaxy? The Milky Way is approximately 100,000 light years across. The Milky Way is a spiral galaxy, as we talked about earlier. Okay, the components of a galaxy are over 40 billion stars, spiral arms where stars are formed, a disk of gas and stars, around 1 million stellar mass black holes, 50 billion planets, and 4.4625 trillion moons, and tens of billions of solar systems. Our solar system. Nova, you want to do these ones?
Yeah. What are the components of our solar system? There are, there are lots of, I can't see the thing behind it, but there is lots of stars in the orbit, but there's mainly, they just count the sun as one star, but 5 dwarf planets, 140 moons, 150 million asteroids if you just count the bigger ones, and there are 6,619 known comets. I don't know. Is that? Yeah, that's me too. Yeah. Where is our?
Libby has asked me to stop to pause. Okay.
Galaxy in the solar system. Our solar system is located in a region between the 2 arms called the Orion Cygnus arm. This arm measures 3,500 light years across and 10,000 light years in length. Where it breaks off from the Sagittarius arm.
Thank you.
Thank you.
Do you want to show our models now?
Yeah.
Oh, yeah.
Who wants to go first?
Probably Maya, because I think she has the best one. I don't know. I haven't seen yours.
Yeah, we can go from smallest to largest, like in scale. So we'd start with the solar system and then go up.
So Nova, you have solar system.
Oh, that's
yeah.
okay. So I don't know how. Can I flip this camera? Can you flip it?
At the top, for me, it has right next.
Size of one face on a normal size die, then the galaxy would be the size of Maryland and Delaware combined. And let's see.
Wow.
And then this is where our solar system is located in the galaxy, just so you can see, like, it's really big, our galaxy. So, yeah.
Okay, so mine is, let me flip it around. Okay, so I have this jello thing. You know, the blue represents the universe and the little dots of random color are galaxies, nebulas, and just like other stuff that kind of resides in there. So I have this thingy too. So the observable space is 93 billion light years, and that's only what we can see. The largest known galaxy is 6 million light years. So Maya did the math. She gets the credit. But imagine a 3.8 foot tall child standing in a football field. And that is that giant galaxy compared to what we know of the universe. But it could be bigger. Because for what we know, it kind of just goes on forever. You know. Fun jello mold thingy. Okay. There we go. Okay. So, yeah.
Okay. That it? Okay. I think that was it. Okay. So I'm going to go and stop the sharing of this. Okay, guys. So we are right at 1 o'clock. So I think that I might have stopped that a little bit prematurely, but John Ben has a question. I think we're going to have to play our Cahoots on Wednesday. Okay, yeah, John Ben, how can I help you?
It's just about one of the questions because you were messaging someone like while it was on the screen and it got covered up. What are the components of our solar system? All I got was 8 planets.
Okay. Does somebody want to take that? Let's see. We'll give, I'm going to just, there's too many people. I'm going to unmute you. Okay. Who wants to take that? Courtney or Maya or Nova? What else is there besides 8 planets?
Is my mic on?
Yes.
Okay, I can answer that. There are 8 planets that orbit a big star, which is the sun. And then there are 5 dwarf planets, 140 moons, 150 million asteroids if you just count the bigger ones. And there are 6,619 known comets. Can you say that again, but slower?
Yeah.
Does that help? Can you say that again, but slower?
Sure.
Okay. There are 8 planets. Yeah, I can. Okay. There are 8 planets that orbit the sun, and then 5 dwarf planets, 140 moons, 150 million asteroids, if you just count the bigger ones, and then 6,619 known comets.
Okay. Thank you.
Okay, thank you.
All right.
And those
Jaden,
are
do
the
you have a
components
question?
of our solar system.
Yes. Okay, I just missed one of them. How many galaxies exist in the universe?
I have that. There are 2 trillion galaxies in the universe.
No.
Okay, thank you.
Really? Is it more?
I think it's 20 trillion, right?
20 trillion?
Yeah, that's what, yeah.
Like that. They think there is, several hundred trillion, I believe. 200 trillion, maybe it's 200 trillion.
I don't know. I just looked it up and it said 2 trillion. So it was 200 billion. 2 trillion.
Oh, yeah. I think you're right. Over 200 billion, more up to 2 trillions in that range. Yep, you're right, Courtney.
Yeah.
Okay. So I am so sorry. This was our first day doing this that it did take longer than I thought. So we'll have to play the Cahoots on Wednesday. Maybe we'll start, those will be like our our warm-ups, and then we'll do our next presentation. And we might only do one presentation on Wednesday, and then 3 quizzes for 2 for this for today. So I hope that everybody got their questions answered. It looks like everybody that had their hand up, if you didn't put your hand down, you probably don't have another question. Okay, I am going to